Somewhere, far away from our world as we know it, a planet orbits a small star in the darkness of space. There are no cities there, no sounds, and no one knows yet what the surface of that world looks like. And yet, this planet has attracted the attention of astronomers. What is the most terrifying that makes any similar discovery fascinating? A giant planet, some of its characteristics, an exploding star among the worlds, or something that can swallow light itself that could potentially support. What you're about to discover is not science fiction, is GG, but real facts about one of the most terrifying and extremely distant compared with everything we know on Earth. The black hole, yet relatively close when we speak. Its name may make it sound like a giant hole, and this is where one of the most fascinating questions in modern astronomy of space, where an enormous amount of matter has collapsed into where life has emerged until its gravity. When we hear the phrase "so habitable, incredibly powerful," we may immediately imagine a world resembling Earth, even light with blue skies, which travels at nearly 300,000 kilometers per second, forms of life moving across its surface. That's why a black hole scientists completely do not use the term any light that reaches it. For them, the presence of a planet within the habitable zone does not mean that they have found life. Nor does it even know that time itself have proven the existence of water on the planet's surface, which we think is constant, that the planet lies within a range of distances. If one person approaches a black hole under certain while another stays far away, temperatures could allow water to exist will tick much more slowly. And this is a crucial point, because only 1 hour may pass. Is considered one of the most important ingredients we look for even when trying to determine whether a distant world could provide an environment suitable for life space. It warps time. Earth itself gives us the best example of this. Despite its terrifying planet is not so close to the sun, there's a common misconception that many people believe. Nor is it so far away that everything freezes and everything in the universe. But distance alone is not the reason life exists here. If the sun were Earth's atmosphere plays a fundamental role in regulating temperature, Earth would not protecting the surface, while providing a complex chemical environment that has allowed life to persist. The only difference is that Earth would be plunged into eternal darkness. When scientists discover a planet located within the habitable zone, they do not say, "Now get ready for something almost impossible to imagine." Instead, they say something more cautious. At the center of most galaxies, we have found a world that deserves further study, billions of times the mass. And this is where GJ337e imagine a single object containing the mass of billions of stars. This world is not compressed into a relatively small region. Instead, the size of a galaxy. It belongs to a category even our own galaxy, the Milky Way, which refers to planets larger than Earth in size dominating the surrounding region, but not large enough to reach the scale. And if a star gets too close to one of such as Neptune monsters or Saturn, it won't simply be swallowed. This category of planets is extremely interesting to scientists. Something even more solar system does not contain a clear gravity on the side of the star closest to the smaller rocky planets becomes much stronger than on the far side, and we have enormous gas to stretch until it turns into a long stream of gas, a different region, almost like a strand of spaghetti. For this reason, scientists discovering them give scientists an opportunity to study types of worlds think that have seeing a black hole is impossible in our solar system. But in 2019, how can humans actually discover a planet image of distant? The surprising part is that the picture wasn't not emit strong light of their own, because that's making them extremely difficult to see extremely hot the light of the star they orbit at incredible speeds. Instead, before astronomers rely on the tiny creating the famous glowing orange ring seen around the world. Imagine a massive star even more and a smaller planet orbiting around it. Not even light. It may seem logical that only the planet is orbiting the star. Some black holes can, but in reality, enormous jets of interact gravitationally, stretch across millions of light years. The planet pulls on the star with a very small force, close to the speed causing the star itself making them slightly around the powerful phenomena in the universe. This movement here's the biggest surprise that it is impossible to imagine a black hole, but it leaves a trace in the light. According to physicist Stephen Hawking, specialized instruments black holes are not eternal. From these changes, scientists can infer the existence of the planet and over an unimaginably long orbit, estimate its mass, and then compare this information gradually with what we know about other planets. Eventually evaporate. What makes the story even more interesting is that this planet an even stranger hypothesis exactly suggesting that the universe may contain stars smaller and cooler, belonging to a type of star known as a red dwarf. Yet these stars are extremely common throughout our galaxy, although scientists and they are much smaller and less luminous than the evidence that they exist. Because they are cooler, finally, the region where conditions could potentially allow liquid water can be much closer to the star. What
This
lies
makes
inside
discovering
some
some
planets within
The
this
truth
region
is
we don't
relatively
know
easier.
Once
Because
anything
the planet is
crosses
very
what is
close to
known
its
as the
star
event
and
horizon,
orbits it more
no
quickly.
information can ever
But
return
there is a
to
major
us,
problem.
leaving every
Being
possibility
so
close
open.
to a red dwarf.
The laws of physics
also
as we
means
know
that the
them
planet
may
can be
completely break
exposed
down
to
there,
strong stellar
and
effects,
phenomena beyond
such
our
as flares
imagination
and
may
radiation,
exist.
which can have a
Even more
significant
fascinating,
impact on its
if a
atmosphere.
person were to fall
And here,
into a
one of the
supermassive
most
black
complicated
hole,
questions
they might
about
not
life
feel
beyond
anything
Earth
unusual
appears.
at the exact
If a
moment they
planet
cross
is
the
very
event
close to its
horizon.
star,
But as they got
it may
closer
become
to the
tidally
center,
locked,
the gravitational
meaning that one
forces would
side
become
always
so extreme
faces the star,
that they would
while
stretch
the other
and
side
tear the body
remains in
apart,
permanent
atom
darkness.
by atom.
A black
At first
hole may be
glance,
the most
this
mysterious
sounds like a
place
disaster.
science has ever known.
How could life
A
exist
place that swallows
on a world
light,
where one half
slows
experiences
time,
perpetual
tears,
daylight
stars apart,
and the other perpetual
and
night?
challenges the very laws
But
of
nature is more
physics.
complicated than that.
And the question that
If
still
the planet
remains
possesses
unanswered
a
is,
suitable atmosphere,
does a black
the
hole
movement
hide
of
the end
gases
of
could help
everything,
distribute heat
or the
between the
beginning of something
star-facing
we have?
side and the dark side? In some theoretical models, the region between day and night could be particularly interesting as an environment for life. But all of this remains theoretical modeling, not evidence that GJ3378b actually possesses these conditions. And this brings us to the most important thing to understand about this discovery. Scientists have not found life on GJ3378b. They have not found plants, animals, oceans, or an alien civilization. Even the presence of water on its surface is not something we can assume simply because it lies within the habitable zone. What we have is a collection of characteristics that make the planet worthy of further study. And the difference between a potentially habitable candidate and a planet where life exists is enormous. In astronomy, moving from possibility to evidence can require years of observation and analysis. One of the most important things scientists want to know is the nature of its atmosphere, if it has one at all. An atmosphere can completely change our picture of a planet. A planet may be located at an appropriate distance from its star, but without a suitable atmosphere, its surface could be extremely cold or extremely hot, or it could be directly exposed to stellar radiation. Conversely, a dense atmosphere could retain a large amount of heat and radically alter the conditions on the planet's surface. That is why studying the atmospheres of exoplanets has become one of the major goals of modern astronomy. And this is where the James Webb Space Telescope enters the story, one of the most powerful tools humans possess for studying distant worlds. James Webb cannot simply point its camera toward GJ3378b and photograph its surface the way we photograph the moon from Earth. The distances are enormous, and the planet is tiny compared with its star. But there is another, more precise method. When a planet passes in front of its star from our point of view, a small portion of the star's light passes through the planet's atmosphere before reaching us. And if the atmosphere contains certain gases, those gases leave fingerprints in the light. By analyzing these fingerprints, scientists can attempt to determine what substances are present in the atmosphere. It is like having a chemical fingerprint of a world we cannot reach. But even this step would not mean that we have found life directly. The presence of water vapor in an atmosphere does not mean life exists, and the presence of methane does not automatically mean life exists either. Even finding a combination of interesting gases would not by itself be enough to announce the greatest discovery in history. Scientists would need to rule out non-biological explanations and make sure that the signal is not caused by stellar activity, measurement errors, or inaccurate models. That is why the search for life beyond Earth is not a race to find the first strange signal. It is a long process of testing, eliminating possibilities, and verifying results. And yet the question remains in the background all the time. What if this world really is different? What if it has an atmosphere? What if it contains liquid water? What if the chemistry on its surface is complex enough to allow life to emerge? Then GJ3378b would not simply be another small point in a database of exoplanets. It would become one of the worlds humanity could look toward and say, there, in that distant place, there may be an environment that in some ways resembles the conditions that allowed life to emerge on Earth. And what is even more fascinating is that GJ3378b is not alone. Since the discovery of the first planet outside our solar system, scientists have begun finding thousands of other worlds. Some are rocky, some are gaseous, some orbit strange stars, and some lie in regions where water could potentially exist. And every new discovery changes something in our understanding of the universe. In the past, we did not even know whether other stars had planets. Today, we know that planets are extremely common and that our Milky Way alone may contain an enormous number of them. And this is where the story of exoplanets becomes more fascinating than simply a story about astronomical discovery. If planets are common, and if some of them lie in regions suitable for liquid water, and if some of these planets possess stable atmospheres, then the question is no longer simply, can life X? And this is where the story of exoplanets becomes more fascinating than simply a story about astronomical discovery. If planets are common, and if some of them lie in regions suitable for liquid water, and if some of these planets possess stable atmospheres, then the question is no longer simply, can life exist? It becomes, how often can life emerge when the right conditions are present? We do not know the answer yet. Perhaps the answer is that life on Earth was an extraordinarily rare event, something that happened only once in the known history of the universe. Or perhaps the answer is completely different. Perhaps life exists in countless places, but enormous distances isolate every world from the others. Or perhaps there is a distant world orbiting a small star, beneath a sky no human has ever seen, where complex chemistry has been taking place for millions of years without anyone knowing that it exists. GJ3378b does not tell us that this scenario is true, but it reminds us of something astonishing. We have finally begun to possess the ability to search. And the question now is not simply whether the universe contains other worlds, but whether one day we will be able to discover what exists on them. In part 2, we will move closer to this planet. We will see what could happen to water on its surface, how its day might be different from ours, and why the star it orbits could be both a blessing and a curse at the same time. And perhaps we will reach the most fascinating question of all. If there is life there, how could we detect it from Earth? We do not know whether it has a sky. Sometimes, the most fascinating things about a scientific discovery are not the things we know, but the things we do not know. And that is exactly what is happening with GJ3378b. We know that it exists. We know that it orbits a small, cool star about 25 light years away. And we know from recent measurements that its minimum mass is around 2.3 times the mass of Earth, and that it completes one orbit around its star in about 21.5 days. We also know that it receives from its star an amount of radiation roughly comparable to what Earth receives from the Sun, which places it within the region where, theoretically, liquid water could exist on its surface. But there is one question whose answer remains completely uncertain, and it may be the most important question in the entire story. Does this world have an atmosphere at all? At first, the question may seem simple, but an atmosphere is one of the factors that can determine the entire fate of a planet. Earth, for example, does not have its moderate conditions simply because of its distance from the Sun. The atmosphere plays a fundamental role in regulating temperature, distributing energy between different regions of the planet, supporting the water cycle, and participating in countless chemical reactions that have made Earth's surface a suitable environment for life. Therefore, two planets can be at similar distances from their stars and receive comparable amounts of energy, yet have completely different conditions. One could be a world covered in water, while the other could be a cold or hot desert without a stable atmosphere. This means that GJ3378b's location within the habitable zone is only the beginning of the story, not the end. Things become even more complicated because the star this planet orbits is a red dwarf. These stars are much smaller and cooler than the Sun, which means that the habitable zone can be very close to the star. In fact, GJ3378b orbits at a distance of roughly 1/10 of the distance between Earth and the Sun,
yet it receives an amount of radiation close to the amount Earth receives. This small distance means that the planet completes its orbit around its star extremely quickly compared with Earth. A year there does not last 365 days, but only about 3 weeks. But being so close to the star brings another, more serious problem: radiation and stellar activity. A world located very close to its star is more exposed to stellar winds and energetic particles, and these factors can affect its atmosphere over millions or billions of years. And here we encounter an idea that scientists sometimes describe using what is known as the cosmic shoreline, or the cosmic shoreline. It is a way of visualizing the relationship between a planet's ability to retain its atmosphere and the amount of radiation and energy it receives. Imagine that a planet's atmosphere is something the planet is trying to hold on to, while the star is constantly trying to strip it away. If the planet has strong enough gravity and its star is moderately active, it may be able to retain its atmosphere for billions of years. But if the radiation is intense and the atmosphere is weak, particles in the upper atmosphere may gain enough energy to escape into space gradually. Recent studies have placed GJ3378b near this sensitive region, which is why the planet has become interesting for two reasons at once. Its location makes it a potential candidate for liquid water, while that same location around a red dwarf could make retaining an atmosphere a major challenge. Now imagine that this planet was warmer early in its history, and that it possessed a large amount of water and a suitable atmosphere. Over hundreds of millions of years, radiation and stellar winds could affect the upper layers of its atmosphere. Some molecules could break apart, while some atoms could gain enough energy to escape into space. Over time, the entire environment could change. The planet might become drier, colder, or lose a significant portion of its atmosphere. But the opposite scenario is also possible. Perhaps the planet retained a dense atmosphere, and perhaps beneath it there are oceans, layers of ice, or even an environment completely different from anything we imagine. The problem is that we cannot determine this simply by looking at its orbit. And here we reach one of the most fascinating paradoxes of this discovery. GJ3378b is relatively close to Earth, but at the same time, it is so far away that we cannot reach it with current technology. 25 light-years may sound like a small number when compared with the size of the Milky Way, which stretches for tens of thousands of light-years, but it is an enormous distance for any human spacecraft. Light itself, the fastest thing we know, takes about 25 years to travel from that system to Earth. This means that the light we analyze today tells us about the state of that system as it was roughly 25 years ago. We are not seeing the planet at its current moment. We are seeing an old image of it that reached us after a journey lasting a quarter of a century. But this distance is precisely what makes the planet an interesting target for scientists. It is not a world at the unknown edge of the galaxy, but one of our relatively nearby cosmic neighbors. And if observational technology advances in the future, worlds like this could become some of the best places to search for chemical signatures associated with life. The problem is that GJ3378b does not transit its star from our point of view. And this is important because the absence of a transit makes studying its atmosphere using some of the methods we use with other planets much more difficult. As a result, some of the tools used to study transiting planets cannot simply provide us with the answer we want here. But suppose that in the future, scientists manage to obtain better information about the atmosphere of this world. What would they look for? The first thing would be water, or rather signs that could indicate its presence. Water vapor in an atmosphere can leave a distinctive signature in the light. But scientists would not stop at water, because water alone does not mean life. Water can exist on a planet where there is absolutely no life. Therefore, scientists would look for more complex chemical combinations, chemical imbalances in the gases, and signals that would be difficult to explain through geological or chemical processes alone. The fundamental idea is not to find a life gas, because that simple concept can be misleading, but rather to search for a combination of evidence that, when appearing together, becomes much more difficult to explain without biological activity. And here things could become truly astonishing. Imagine a device on Earth receiving an extremely faint light coming from a star 25 light years away. Then computers begin analyzing that light, and a collection of tiny lines appears in the spectrum. At first, they mean nothing. Then scientists compare them with models of different gases and discover the presence of water vapor. It is still not enough. Then a signal from another gas appears. After that, a third gas. Each one of them could have a non-biological explanation. But the problem begins when these signals appear together in a way that makes a biological explanation worth taking seriously. At that moment, scientists will not have seen a living organism, and they will not be able to immediately say that they have discovered life. But they may have found something more important than simply a habitable planet, a signal worthy of making the entire world turn its attention toward that star. And yet it would be very easy for people to make the same mistake that happens with every exciting discovery. A headline such as "Scientists Discover Life Beyond Earth" would be extremely attractive, but it would be completely different from the scientific reality. Science does not work that quickly. If an intriguing signal appears, other scientists will try to analyze the data again. They will look for instrument errors. They will test contamination possibilities. They will study stellar activity, and they will try to determine whether geological or chemical processes could produce the same signal. If the signal disappears after further observations, it may turn out to have been nothing more than noise or a measurement error. But if it remains, appears in independent measurements, and alternative explanations can be ruled out one by one, then things begin to move from mere possibility towards strong evidence. And this is why the discovery of life beyond Earth, if it ever happens, will probably not be a cinematic moment in which we see a strange creature in front of a camera. It may be much quieter than that. It might begin as a small line on a graph, a slight change in a light spectrum, or a collection of numbers that seem completely uninteresting to an ordinary person. Then scientists begin to realize that these numbers may contain something we have never seen before. Perhaps after years of testing, the scientific community becomes convinced that there is a phenomenon that cannot easily be explained except through the presence of a biological process. But before we reach that stage, there is another problem that must be solved. Could life actually exist on a planet like GJ3378b under a red dwarf star? Because there is another side to the story that we have not discussed yet. A red dwarf is not simply a smaller, cooler version of the Sun. Its stellar environment is different, and its interactions with a planet can be different as well. If the planet is tidally locked, one side may constantly face the star while the other remains in perpetual night. This may initially seem like a world unsuitable for life, but climate models suggest that an atmosphere and oceans, if they exist, could redistribute heat. There may be regions with moderate conditions between the illuminated and dark sides. Again, we do not know whether these conditions actually exist on GJ3378b, but the possibility alone shows how different worlds beyond our solar system can be from our own. And perhaps this is the most astonishing thing about the entire story of exoplanets. When we first began discovering these worlds, we were searching for other versions of Earth. But the more we discovered, the more we realized that the universe does not work that simply. Some planets are worlds of rock, some are covered in gases, some are extremely hot, some are icy, some orbit two stars, and some exist under conditions with no equivalent anywhere in our solar system. And perhaps life itself may be capable of adapting to environments far more diverse than we imagine. In the end, GJ3378b remains only a potential candidate, not a confirmed second Earth. Its new mass estimate makes it more likely to be a potentially rocky world than previous estimates suggested, and its position in the habitable zone makes it an important target. But this alone does not tell us whether it has water, an atmosphere, or life. Even now, the biggest missing piece of the puzzle is the sky above that world. Is there an atmosphere protecting its surface? Is there water? Did it lose its atmosphere over a long history of interaction with its star? Or has it managed to retain it until today? These questions remain open, and perhaps that is exactly why this planet deserves our attention. Because for the first time, we are not simply talking about a distant world discovered in a database, but about a relatively nearby world located in a region that could allow liquid water with a new mass estimate that makes it an even more interesting candidate for studying rocky worlds. It is not evidence of life, but it represents something extremely important, a new opportunity to search. And now imagine the question that will remain hanging at the end of all this data. If this world has an atmosphere, and if it contains water, and if the conditions are suitable, could life have emerged there as well? And if it did, would it be similar to life on Earth? Or can nature produce life in forms that are completely different? More importantly, if we discovered that life had emerged on another world only 25 light years away, what would that mean about the rest of our galaxy? Because 25 light years may seem far away to us. But on the scale of the universe, it is a very short distance indeed. And perhaps this small world is merely the first real window we open onto a question humanity has been asking for thousands of years. Are we alone? In part 3, we will move from the question, could this planet be habitable, to the much harder question, how could humans actually prove that life exists on a world they cannot reach? And we will see why the answer may be hidden in the light itself, and why a single molecule could one day change the way we see the entire universe. What if we are not alone? There is a moment in the search for life beyond Earth that is unlike any other moment. A moment that does not require you to see a strange creature, send a spacecraft to a distant planet, or even capture a clear image of its surface. The moment could begin with nothing more than light, an extremely faint light that has traveled nearly 25 light years before reaching a telescope on Earth. That light carries with it an ancient history of a distant star system, and perhaps something even more important, a chemical signature from a world we cannot reach. And this is where one of the greatest ideas in modern astronomy lies. We do not always need to travel to the stars to know what is there. Sometimes we only need to know how to read the light. Almost every chemical element leaves a distinctive signature when it interacts with light, which is why scientists can analyze the spectrum coming from stars and planets and infer what substances are present. Imagine seeing white light pass through a glass prism and separate into multiple colors. If that light passes through a certain gas before reaching you, some colors become weaker than others because the molecules of the gas absorb specific wavelengths. By analyzing these changes, scientists can determine whether there is water vapor, carbon dioxide, methane, or other molecules. And in the case of a planet like GJ3378b, this information would be extremely important because it could tell us for the first time about the nature of the environment surrounding this world. But there is a problem. Knowing that a planet has an atmosphere is one thing, while knowing that this atmosphere contains life is something entirely different. Nature can be deceptive. Some of the gases we associate with life can also be produced by volcanoes, chemical reactions, or geological processes. Even on Earth, where we know with certainty that life exists, there are many natural processes that produce molecules that could look intriguing if we observed them on a distant planet without knowing its full context. Therefore, scientists would not look for a single molecule and say, "We have found life." Instead, they would try to build what is sometimes called a biosignature from a combination of evidence. If they found several gases together in proportions that were difficult to explain through non-biological processes, if the signals remained present when observations were repeated, and if the effects of the star and geological processes could be ruled out, then the possibility would become far more intriguing. But even then, scientists would remain cautious, because announcing the existence of life beyond Earth would not be just another scientific news story. It would be one of the greatest intellectual transformations in human history. For thousands of years, the question of life beyond Earth has been simultaneously philosophical, religious, and scientific. Are we alone? Is Earth an exceptional case? Is life the result of an extremely rare chain of coincidences, or does it emerge whenever the right conditions are available? In the past, we had no practical way to test these questions. Today, we have begun to develop the tools that could allow us to approach an answer. And this is where the existence of thousands of exoplanets becomes so important. When scientists discovered the first planet orbiting a sun-like star, it was a monumental event because for the first time, we had clear evidence that our solar system was not the only model. But over time, discoveries transformed from rare exceptions into a vast cosmic landscape. We began to learn that planets are widespread throughout the galaxy and that they come in an enormous variety of sizes, temperatures, orbits, and compositions. Earth no longer appears to be a solitary island in an empty ocean of planets. It is one of many worlds, even though we still do not know whether it is one of the many worlds where life has emerged or a completely exceptional case. And if life has emerged on GJ3378b, the question will not simply be about finding another living organism. The real question will be, how did it emerge? And did it arise through a process similar to what happened on Earth? We know that life on our planet depends on extremely complex chemistry, water, energy sources, and many chemical elements. But we do not know whether this is the only way life can begin. Perhaps there are other pathways we have never imagined. Perhaps life exists in environments that are extremely cold, highly acidic, or based on chemistry fundamentally different from the environments we are familiar with. That is why finding life beyond Earth would not only answer the question, does life exist? It could force us to redefine what we mean by the word life in the first place. And yet there is something we must not forget. GJ3378b itself is not necessarily the best place in the universe to find life. It is simply one of the nearby and interesting worlds that deserves to be studied. Scientists do not yet have evidence that it has an atmosphere, nor direct evidence of water on its surface, nor any evidence of life. Its scientific value comes from somewhere else. It represents an opportunity to study a world located in a region that could be suitable for water, orbiting a relatively nearby star, and possessing a mass that makes its nature particularly interesting. And with every new piece of information we obtain about it, we can learn more about how planets evolve around small stars. And perhaps one of the most important future results would be the discovery that this planet has completely lost its atmosphere. That may sound like bad news for the possibility of life, but it would still be an extremely important scientific discovery. It would tell us how difficult it is for atmospheres to survive around red dwarfs, and it would give scientists information about the effects of stellar activity on nearby planets. It could also help us understand thousands of other planets orbiting similar stars. In science, even a result that rules out life can be extremely valuable because it narrows the range of possibilities and tells us where we should look next. The opposite scenario is also possible. We may discover that GJ3378b retains a dense atmosphere. Then the story changes. The question becomes, what is this atmosphere made of? Does it contain compounds that could indicate a stable environment? Can the atmosphere maintain suitable temperatures? Is there evidence of water? And can the planet maintain these conditions for long periods? Because life, at least as we know it, needs time. Not merely a brief moment of suitable conditions, but a relatively stable environment that allows complex chemical processes to continue. And here we reach a very deep point in the story of this planet. Habitability is not a switch that is either on or off. There is no moment when a planet suddenly becomes habitable. It is a long chain of conditions. There must be suitable energy, suitable chemical materials, perhaps water or another suitable solvent, a sufficiently stable environment, and conditions that allow complex chemistry to occur. And even if all of these things come together, there is no guarantee that life will emerge. Earth itself tells us this. The presence of suitable conditions does not mean that life must appear immediately. The history of life on Earth is long and complex, and scientists are still trying to understand how it began in the first place. That is why discovering life on another world would be more important than simply finding another alien. It would be an enormous natural experiment. We currently have one laboratory that we know produced life, Earth. If we find a second, completely independent laboratory somewhere else in the galaxy, comparing the two would be extraordinary. If life in both worlds relies on the same fundamental chemistry, perhaps there are universal rules governing life throughout the universe. But if we find life that is radically different from ours, it could mean that nature is capable of producing biological complexity through pathways we have never imagined. But what if we find nothing? What if we study GJ3378b, then dozens of other planets, then hundreds of them, and find no convincing evidence of life? Would that mean we are alone? Not necessarily. Life could exist, but be too distant for us to detect. It could exist beneath the surface of a planet or moon where light from the outside cannot reveal it. Or life could be so rare that we simply have not searched in the right place yet. The universe is so enormous that failing to find something on a few thousand planets would not be enough to prove that it exists nowhere else. The opposite is also true. Finding life on even one world would dramatically change the probabilities. Because if we knew that life had emerged independently in two different places, then the idea that the emergence of life is an extremely rare event would become much harder to defend. It could mean that the universe contains an enormous number of environments capable of producing life, and that Earth is not an exception, but one example among many. And then the question would become, why have we not seen it yet? And here we encounter the Fermi paradox, which can be simplified into a famous question. If the universe contains such an enormous number of stars and planets, and if intelligent life can emerge elsewhere, then where is everyone? Why do we not see other civilizations? Why do we not receive clear signals? Why do we not see evidence of advanced technology? There is no confirmed answer to this question, and there are dozens of hypotheses, but discovering simple life on a distant planet would be a very important step in this discussion. Because life is not the same as intelligent life. Life may be common while complex life is rare. Complex life may be common while technological civilizations are extremely rare. Or civilizations may exist, but be too short-lived, too distant, or use forms of communication that we cannot detect. But all of this begins with one step: finding a world worth searching. And this is why the story of GJ3378b is not the story of we discovered a planet inhabited by aliens. That is not the truth. The real story is more fascinating in a different way. We live in an era in which humans have become capable of discovering planets around other stars, measuring their motion, estimating their masses, studying the light coming from their systems, and attempting to determine whether they possess atmospheres. Only a few decades ago, these things were not possible in the way we practice them today. Now we have begun creating lists of worlds where conditions may be suitable for life, and then trying to determine which ones offer the strongest evidence. And GJ3378b is one of those worlds, a world probably larger than Earth, orbiting a small star, completing an entire year in about 3 weeks, and located in a region where liquid water could potentially exist. But it is also a distant world. We do not yet know whether it has an atmosphere, and we do not know whether its surface is covered in water, rock, or ice. We do not know whether life has ever emerged there at any point in its history. All we have are light, gravity, mathematics, and the instruments humans have built, and these things give us a tiny window into an entire world. And perhaps this is the most humbling aspect of astronomy. When we look at a beautiful image of an exoplanet, it may seem as though we are actually seeing it, but most of the images we see in the news or in films are not real photographs of the planet's surface. They are artistic representations based on the data scientists have collected. The reality is far more modest. A point of light, a tiny change in the motion of a star, a faint signal in a spectrum, and then years of analysis. From these small traces, humans construct a picture of a world that no one can visit. But sometimes, these small traces are enough to change our understanding of the universe. Imagine returning to Earth and looking at the sky on a clear night. Most of the stars you see appear as tiny points with no visible details, but behind one of those points could be an entire star system, a planet orbiting its star, perhaps a moon orbiting that planet, perhaps oceans we know nothing about, perhaps an atmosphere, perhaps complex chemistry, or perhaps nothing more than silent rocks. We cannot know any of this simply by looking at the sky with the naked eye. Then you remember something else. If the light we see from GJ3378b has taken roughly 25 years to reach us, that means that anything happening there now will not be visible to us for roughly another 25 years. We always look into the past when we look at the stars, and every exoplanet is an ancient message arriving late through the void. Therefore, if we one day discover a signal indicating life there, we will not necessarily have discovered life that exists there at the exact same moment. We will have discovered evidence that something was happening there when that light left the planet. And this leads us to a very strange possibility. What if we discover years from now that a distant planet has an atmosphere carrying strong signs of life, and then it turns out that those conditions have changed? What if life existed there in the past but no longer exists? Or conversely, what if life began after the light we are analyzing had already left? We cannot stop time, and we cannot send a message faster than light. Therefore, studying the universe is in part studying the history of the universe. And perhaps this is why we should not expect GJ3378b alone to give us the answer to the great question. Perhaps it will not be the planet where we find the first evidence of life. Perhaps it will be another world we have not yet discovered. Perhaps it will be an icy moon in our own solar system. Or perhaps it will be a planet hundreds of light years away. We do not know, but every new planet adds another piece to the puzzle. Every atmosphere we manage to analyze adds another piece of information. Every negative result rules out a possibility. Every strange signal makes us reconsider. And eventually, the day may come when light reaches one of our telescopes that is different from everything we have studied before. It may not be bright, it may not be clear, and it may not be exciting to the human eye, but it could carry a chemical signature that known natural processes cannot easily explain. Scientists would then begin observing it again. Other teams would join the process. Scientific papers and debates would follow, along with attempts to explain the signal, perhaps over years of testing. And if the signal remains, if it remains after every attempt to disprove it, if every non-biological explanation fails to account for it, then perhaps we will reach a sentence that no scientist has yet dared to say with certainty. We are not alone. And when that moment comes, the most important thing will not be the form of the life we found, nor the name of the planet, nor the distance separating us from it. The most important thing will be what it means, because we will finally have obtained an empirical answer to a question humanity has been asking since it first began looking at the sky. Life is not merely an event that happened on Earth. It is a phenomenon that can happen on another world. And then our view of Earth itself will change. We will look at our oceans, our atmosphere, and our living organisms differently. We will understand that the planet we live on is not simply a familiar place we take for granted, but one of the few worlds we know with certainty to have transformed non-living matter into living systems capable of growing, evolving, and reproducing. But for now, the question remains open. GJ3378b is not a confirmed second Earth, and it is not evidence of life. It is a distant world with some characteristics that make us raise our eyes toward it and say, perhaps. And perhaps the word perhaps is the most important word in science, because perhaps means that there is something we do not know yet, and that there is a question that can be tested, and that there is a distant world waiting for us to read what its light has to tell us. And perhaps one day, the question will no longer be, is there life somewhere else? But instead, how many worlds have life on them?